Hi, this is Lee from the Robby team. In this video, we're going to use the Robby framework and start to play with the ultrasonic range sensors that are arrayed around the body of my robot named Antwerp. You can see that I've put the side panels onto the robot, which have the sensors mounted inside little white boxes. I made the boxes and in fact all of the plastic mounting hardware used by the bot on my 3D printer here in my workshop. There's 6 sensors in all, one on each side and extra ones at the front and back up higher and facing down at a 45-degree angle. It's probably obvious that those are because I have stairs in my house where I'm mostly be running the robot. In previous videos I said these sensors are for collision alerting and avoidance. What I meant by that is the sensors should alert the MCP when one's range signal drops below a certain value, meaning a surface is getting too close. Of course, that's an exception to the 2 down-looking sensors. The alerting becomes avoidance if the MCP doesn't signal the robot to stop before the value hits another lower limit. In that case, the Arduino card itself will stop the motors, hopefully in time to avoid a collision or having Antwerp try to walk down the stairs. So it'll act as sort of a fail-safe feature. Of course, I'll also have the 360-degree LiDAR at the top platform of the bot that will give a much more detailed picture of distances than the range sensors. But it will be sitting close to 3 feet higher, and the image it will produce will be of a thin stripe at that height. So these sensors are to make sure we're watching down low as well. This will also be the first time I demonstrate using the framework to receive data initiated at the robot, as opposed to just responses to messages coming from the MCP. I'll do this by subscribing to events raised by the framework in the simple MCP program that I began implementing in the last couple of videos. As with last time when we ran the treads, we're going to start by showing the functionality in action. So I'm first going to open the same simple program we looked at before that's written on top of the Robby framework. And there that is. You can see that I've added readouts for the 6 sensors next to the 5 buttons that run the tread motors. Below that, I've also added a text box to display the responses I get from the Arduino when motor commands are sent. Now you can also see that if I block in front of the left-hand sensor, the readout for that value will drop. You see it's 62 now, and we block in front of it and it drops down below 10 with it really close. So you can see that it's working. Actually, only 3 of them are working right now, the front and the right and left, but I think you can get the idea. At the same time, I can still run the motors just fine with no interference from reading the sensors. So let's take a quick look at the code I wrote to make this happen. As with the previous video, we'll start by looking at the code behind the WPF form. At the top you can see where I instance the MCP-derived class named Antwerp MPC. But now I've added code to subscribe to 2 events raised by the MCP, named Receive Sensor Message and Receive Command Message. You can see the 2 handlers for these events below, where I set the appropriate text boxes to the values received from the Arduino. Now we'll look at the code I added to the MCP to wire up these events raised by the framework. So you can see at the top where we derived from the master control program base class, which exposes the framework's functionality. And down here where I set up the 2 events with delegates that I subscribe to at the UI form. The interesting part is in the constructor, where I subscribe to events exposed by 2 objects housed in a dictionary collection exposed by the framework. You can see the handlers for these 2 events down here. All they do is pass the message received to the WPF form by invoking the appropriate event. Now I'm going to jump to the definition of the collection, and you can see the full public interface of the MCP base class, including the dictionary we're working with. Go to definition, and here is what's exposed by the framework's master control program base class. The dictionary we're working with is a thread-safe concurrent dictionary collection of a class called MCP Message Event Wrapper. This is a dead simple little class that just contains a public event as well as a method to invoke it. The dictionary contains an element for each channel on the robot's network, which each runs on its own thread. So that's the code it took to receive the readings from the range sensors using the network. That's it for this video. In our next one, we'll look at the changes I made to Antwerp's network in the UI of the Robby framework. Bye for now, and please stay safe and healthy.